This session is for OCR FP2. We're doing June 2010 question 9, and the question involves integration and polar coordinates. So let's have a look first of all. So we've got a diagram here showing the curve with equation y equals root 2x plus 1 between these points A and B. We're asked to find the area of the region bounded by the curve, the x-axis, and the line x equals 4, and hence find the area of the region bounded by the curve and the lines OA and OB, where O is the origin. In part 2, show that the curve between B and A can be expressed in polar coordinates in this form, r equals 1 over 1 minus cos theta, where we're given a range of values, which we'll need to make sure we can show correctly. And then in part 3, deduce from parts 1 and 2 that the integral between inverse tan of 3/4 and pi of the cosec to the power of 4 over half theta d theta is equal to 24. So 13 marks in total for the question. So let's have a look first of all at part 1. So in part 1 we have the curve y equals 2x plus root 2x plus 1. We want to find the area. So we're going to integrate 2x plus 1 to the power of a half between negative a half and 4. And if we integrate that, what we will get is 2x plus 1 to the power of 3 over 2. So we add 1 onto the power, we divide by the power 3 over 2, we also divide by 2, so effectively it's going to be over 3. And then if we substitute in our limits, when x is equal to 4, we have 9 to the power of 3 over 2, which is 27 over 3, which is 9. And when x is equal to negative a half, we get nothing. So the area that we're asked to find under the curve, between the curve and the x-axis, is 9 square units. We're then asked to find the area bounded by OA and the curve and the line OB. So effectively we are wanting to find this area in here. So what we'll need to do is we'll need to find the area of the triangle OB down to this point 4. So the area of the triangle then will be a half times 4 times root 2x plus 1 when x is equal to 4, so that's going to be 3. So the area of the triangle is 6, and so the required area is 3 square units. So there were 4 marks for that question. If we just check on where we're getting those marks, we got a method mark for the integration and an accuracy mark for finding that the area under the curve was 9. We got a method mark for seeing that we needed to find the area of the triangle, and an accuracy mark for ending up with the correct answer. So in part 2 then, what we're asked to do in part 2 is we're asked, this is the bit which involves polar coordinates, we're asked to show that the curve can be expressed as r equals 1 over 1 minus cos theta. So the curve we're looking at is this one here, and it's between these 2 points, and we'll need to use those 2 points to establish the limits. So let's just check on how we're going to do that. So we've got here, I've just reminded ourselves about the way we can change from Cartesian to polar coordinates. So we have y equals root 2x plus 1. So y is r sine theta, and that's going to be equal to root 2x plus 1. So that's going to be root 2 cos theta, 2r cos theta plus 1. And then we're going to square both sides, because we need to get rid of that square root sign. And now what we need to see is that we've actually got a quadratic in R. So I'm just rearranging that in terms, so we've got an r squared term, an r term and a constant, and we will now need to use a quadratic formula. So minus b is going to be minus negative 2 cos theta, so that's 2 cos theta, plus or minus the square root of b squared, which would be 4 cos squared theta, minus 4ac, which is going to be minus 4 sine squared theta. And that's all over 2a, which in our case is going to be 2 sine squared theta. So hopefully you can see that under the square root sign here we've got 4 cos squared theta plus 4 sine squared theta, which of course is just 4. And so we end up with 2 cos theta plus or minus 2. And that's all over 2 sine squared theta. So what we need to do now is just see if we can get that in the form that we want it in, r equals 1 over 1 minus cos theta. So let's just have a look at that. First of all, we need to see that we can divide through by 2. So on the top line now we're going to have cos theta. And I should also say that we know that r is greater than 0, so we just need the positive sign. So cos theta plus 1 on the top, and on the bottom line we have sine squared theta, but of course we know that sine squared theta is 1 minus cos squared theta, and we also know that we could factorise 1 minus cos squared theta using the difference of 2 squares to get 1 minus cos theta times 1 plus cos theta. And of course you can see now that we actually can now divide top and bottom line by cos theta plus 1, and we end up with r equals 1 over 1 minus cos theta. So we have been able to do that. What we now need to do, as I say, we needed these points A and B because we need to make sure that we have the correct range. So at B, what do we know? At B we know that x is equal to 4 and y is equal to 3, because remember that's root 2x plus 1 when x equals 4, so that's going to be 3. So that means that tan of theta is going to be 3 over 4, and theta is tan to the minus 1 of 3 over 4. And then at A, over here, we know that x equals negative a half and y equals 0. So that means that tan theta is equal to 0, and the value that we want will be theta equals pi. So we now established that theta lies between tan to the minus 1 of 3/4 and pi. So there were 5 marks for that question, and if we just go back and have a little look at how it all sort of happened, we got a mark here for using the right way for converting from Cartesian to polar coordinates. We got a method mark for substituting in and getting a quadratic, an accuracy mark here for rearranging it in this form, and also another accuracy mark here for seeing that you could rewrite the denominator as cos squared theta, 1 minus cos squared theta, and factorising it, simplifying it here. So another mark there, and then you got a B mark for showing your limits correctly. So 5 marks for that question. And in part 3 now, what we need to do is, it says deduce from parts 1 and 2 that the integral of cos to the power of 4 a half theta d theta that's between negative tan inverse tan of 3/4 and pi, so that should say a pi here, is equal to 24. So what we need to remember is we've now converted it into polar coordinates, and the area under a graph expressed in polar form is given by a half r squared d theta. And our equation was r equals 1 over 1 minus cos theta, so that was how we'd expressed it. So we're going to square that, and we get 1 minus cos theta all squared. Now, in order to do that, what we have to use now is the double angle formula. So we need to be very careful how we actually do this in the denominator. So using the double angle formula, then cos theta will be 1 minus 2 sine squared theta over 2, but on the basis that we're going to be subtracting that, then we're going to end up with 1 minus 1 plus 2 sine squared theta over 2. So you just need to see at that stage that we do need to use the double angle formula. And now we're integrating with respect to theta. And those ones, of course, go out. That'll be squared. Put that in. So the ones cancel out, and we end up with 2 sine squared theta over 2 all squared, which is 4 sine to the power of 4th theta over 2 d theta, which of course is 1/8. That's taking all the fractions outside here, the 4 and we've got the half already, and that of course is cosec to the power of 4 of theta over 2. Now that is an expression for the area that we're looking for, but of course we've already found that that area was equal to 3, because we found that in part 1. So we have found that the area is a 3, so that means if we want to find cosec without the 1/8, the integral of cosec to the power of 4 a half theta, theta over 2 d theta, then equals 24. So that was between pi and tan to the minus 1 of 3/4. So we have been able to establish that. So 4 marks for that. And again, if we just have a quick look at how those marks are allocated, then you did get a B mark for remembering how to find the area of the sector, and that's what we've got there. A method mark for using the double angle formula here correctly. A method mark for establishing that the area of that sector is 1/8 of the integral of cosec to the power of 4 theta over 2. And then seeing that in actual fact we didn't want the 8th there, so we'll just multiply the area by 8 to get the 24. So there was an accuracy mark just for that last little bit. So don't forget that if you want to access further revision videos, then you can do so by going to the Further Maths Support Programme website and following the link.